Greetings and salutations, everybody. How's everybody doing? Hope you're having a splendid day or evening, depending on where you're at. Another day, another puzzle. A puzzle a day keeps the doctor away, as they say. And boy, do I have an interesting puzzle for you all today. It's a tank mixture problem. So let's get right into it, shall we? A tank initially contains 20 liters of water, in which 40 grams of salt is dissolved. A solution containing 6 grams of salt per liter of water flows into the tank at a constant rate of 5 liters per minute, and the mixture flows out at a constant rate of 6 liters per minute. The question is, how many grams of salt are in the tank after 10 minutes? Pause the video if you'd like to give this problem a try, and smash that play button when you're ready to go. So how do we go about solving this problem? Let's start out by expressing the change in volume over a small period of time. Let's call it change in volume delta V, and the small passage of time, let's call it delta T. So delta V is going to be R1, the rate in which water flows into the tank, times delta T, minus R2, which is the rate that water goes out of the tank, times delta T. And this equals R1 minus R2 times delta T. This is delta V over delta T equals R1 minus R2. The rates are constant, they're not changing. And this delta V over delta T equals the instantaneous change of volume over time. dV over dt equals R1 minus R2, which is minus 1 liters per minute. Now let's go to the change in mass of the salt over time, over a small time passage delta T. So delta A is equal to C1, which is a concentration of salt that's inflowing, times R1 times delta T, minus C2, which is a concentration of salt that's leaving the tank, which we don't know yet, it's unknown, times R2 times delta T, which equals C1 R1 minus C2 R2 times delta T. And this equals delta A over delta T equals C1 R1 minus C2 R2. Now notice C2, the outflowing concentration of salt, isn't constant. It's changing over time. It's equal to A of T, which is the instantaneous amount of salt in the tank, over V of T, the instantaneous amount of water left in the tank. And we take the limit of both sides as delta T goes to 0. And we get dA over dt equals C1 R1 minus A of T R2 over V of T. Okay, now let's express V of T in terms of T. Since in the previous equation, we concluded that dV over dt equals minus 1. So we separate the variables, dV equals minus dt, and we integrate both sides. And we get V of t equals constant C minus t. So how do we go about finding this constant? Well, we use the initial conditions. The initial volume of water in the tank is 20 liters. So V of 0 is 20. So we substitute these values in the equation, and we get C equals 20. So V of t is 20 minus t, and we substitute that in the previous equation. Now we get dA over dt equals R2, which is 6, over 20 minus t times A of t equals 30. And this equation is a first-order linear differential equation. And the general solution of this type of equation, dy dx plus p of x times y equals q of x, y times e to the power of integral p dx equals integral q times e to the power of integral p dx plus c. And that's the general solution of a first-order linear differential equation. Let's try to figure out e of e to the power of p dx. So pt in the equation we just derived equals 6 over 20 minus t. Okay, so e of integral 6 over 20 minus t dt equals e times 6. We take the constant out of the integral, times integral 1 over 20 minus t dt. And the integral of 1 over 20 minus t, through our integration rules we've taken calculus 2, we know that this is ln of the absolute value of 20 minus t. And through the exponent rules, we have e to the power of ln absolute 20 minus t to the power of negative 6 equals 20 minus t to the power of negative 6. Okay, so we substitute this in the general solution of the first order linear differential equation, and we have a times 20 minus t to the power of negative 6 equals integral 30 times e to the power of integral p dx plus c. And we do the calculations. and we end up with A equals 20 minus t to the power of 6 times bracket minus 6 times 20 minus t to the power of negative 5 plus c. So we have another constant we have to figure out. We figure it out by using the initial conditions. At t minus 0, we have 40 grams of salt in the water tank initially. So we plug those values in and we do the calculations. And so c is equal to 160. So now that we got c, now we can figure out how much salt we have after 10 minutes. So we plug in t equals 10 in the equation we just figured out. We end up with 100 grams of salt in the water tank after 10 minutes. And that's your answer. 100 grams, which, if you ask me, is an intuitive answer. So yeah, that was a pretty interesting differential equation puzzle. I hope you liked it. I don't think it was too difficult to figure it out. So yeah, if you like this puzzle, then smash that like button, subscribe, comment below what you thought, if you found it difficult or not. And I'll see you guys in the next video. Bye-bye.